Hello, this is lesson 20 of the Hetman core. In this tutorial, we will be starting the wishbone interface. The wishbone interface. So, what is this wishbone interface? The wishbone interface is our upper layer interface. So, the wishbone protocol. We have this wishbone protocol for communication. It's a form of communication protocol. So here we're going to be using it for interfacing our Hetman core to the upper layer. So, and as I said in the beginning, this core will be accessing the memory. So it's more like a DMA, the direct memory access. It's not communicating with the processor, it's communicating directly with the memory. So this wishbone is more like an interface to this memory. So why we use the wishbone is that the wishbone is a universal protocol. I urge you, if you don't know anything about the wishbone, it's very good to learn it before going through this tutorial, especially when I'll be talking about the wishbone circuit in the next two tutorials. So it's very crucial and necessary to learn about the wishbone because it's a whole protocol on itself. We are just using it to interface to the memory that we'll be using for this tutorial. So for now, this part is still easy. We'll be talking about the memory itself, the RAM, that we'll be using for storing and accessing this data. So this tutorial can be found at projectfpga.com/tcp select spram circuit. So this is the verilog code. I'll be explaining this as usual in Logisim. This is the circuit. So this here is the usual RAM. We think we know this is the RAM. That is the RAM. So we'll just be talking about this external circuitry here. This is what the code entails. This external circuit, this is what the code entails. So the RAM already is within your FPGA, so you won't be writing much code there. So the code still gives specification depending on what board you are using and what RAM you are going to be using also. So we know the common features of a RAM. It's going to have its output, it's going to have its input, it's going to have the chip enable, it's going to have the output enable, it's going to have the address. What address do you want to access? The clock, the reset, the write enable chip. So all these are the normal basic function of every RAM, but I'm still going to explain it a little bit further for us to understand what the verilog code looks like. So let's talk about this, our data output. How do we output data? So let's know first of all that this is a tri-state buffer. It's a tri-state buffer here. That is, when you don't enable it, you have a high impedance output. Nothing, you won't see 0, you won't see 1. So to enable it, so that we'll be able to see our output, you have to enable this chip enable needs to be on, and your output enable likewise needs to be on. So I think I will simulate this. Let's see. I will simulate it. So as you can see, we just said let me enable this chip. Enable has to be on one. You can see then the output enable likewise. So that is when you can be able to have an output. That is what triggers the output. So here you can now choose what address are you trying to access. What address are you trying to access? You can likewise see the address select moving from one part of the code to another. As I change this address, is moving from different parts of the circuit there. So, and once it's selecting each of them, is outputting. So that is the process of reading from the RAM. So in a situation where we would like to write to the RAM, similar process, but here we have to first of all set what data are we writing here. So I'm setting some random data, and let's know is a 32-bit RAM. So I'll set whatever data I would like to write. Then I'll select the address also. Then I will select what part of this data I would love to write. That is this write enabled. So after selecting the address, you still have to come down here and select what part of this data are you writing. The first 8 bits, are you writing the last 8, the next 16 bits. So this is what this particular the write enable here does. What part of your 32-bit input would you like to write? What part of it are you writing? And you can see the data out is likewise outputting it. So I can decide to say I just want to write only the first 8 bits here. That is the first 8 bits of this input. Then I'm going to do this. This is what I have to do. Make the first one 1, the rest 0. So that is how I'll be able to write it. So what's the logic behind this? We can see what's happening here. First, your chip enable comes down and fits into these 4 AND gates, meaning that without the chip enable you can't write anything. So when it comes down here, it fits into these 4 AND gates, and then on the other side of the AND gates, see where it fits in to the 4 AND gates. Then the next input to the AND gates are each of these write enable signals. This is the wire splitter that splits each line. So if you select 1 on the first one, this AND gate will turn on. If you select 1 on the last one, this AND gate is going to come on. And if they come on, they are going to enable each of these multiplexers. And these multiplexers are what chooses if it's the first 8 bits, the next 8 bits, the third 8 bits, or the last 8 bits. Which one are you writing? So that is exactly how this register works. Don't think there is anything more. We can likewise replace this RAM with the default RAM I designed, or you don't really need more to know much about the RAM itself, because your FPGA has the RAM. Even the code didn't write much about the RAM itself. So everything was about the security that enables you to read or write from the RAM. So that is it. This is a very simple one. You can go through the code to understand more about this. Please subscribe to my channel. Thank you.